In the previous video, we covered addition and subtraction of binary numbers. You can find the link to that video in the cards above or the description below. In this video, we will be getting into multiplication and division of binary numbers. With no further delay, let's jump into multiplication. Let's recollect how we perform multiplication of decimal numbers. To perform multiplication in decimal, we memorize the so-called multiplication tables. Consider this example. We start by multiplying the first digit of one number with all the digits of the other number from right to left. So 1 multiplied by 2 is a 2. 1 times 3 a 3. 1 times 1 a 1. Then we move to the second digit of this number. We now multiply this digit with all the digits of the first number just like we did previously. As this digit is in tens place, we note the result one step shifted to the left, that is starting from the tens place. So 3 times 2 is a 6. 3 times 3 a 9 and 3 times 1 a 3. Similarly, we move to the next digit and repeat this process. As this digit is in hundreds place, we note the result 2 steps shifted to the left, that is starting from the hundreds place. So 2 times 2 is a 4, 2 times 3 a 6 and 2 times 1 a 2. Since all the digits are completed, we now add all these partial results to get the actual result. And so the result of multiplying the given two numbers is 30,492. With this knowledge, let's now understand multiplication of binary numbers. Fortunately, the multiplication tables in binary are just 4 rules. 0 multiplied by 0 is obviously 0. 0 multiplied by 1 or 1 multiplied by 0 is also a 0. 1 times 1 is a 1. Let's now understand multiplication in binary. Consider these binary numbers. Just like decimal multiplication, we pick the first digit of one number and multiply it with the digits of the other number from right to left. So we need to perform 1 times 1. From the multiplication table above, we know that 1 times 1 is a 1. Next we multiply 1 times 0. Refer the table and note the result. Then we have 1 times 1, which is again a 1. And so we multiply the rest. Just like decimal multiplication, we now move to the second digit and repeat the same procedure. Just remember to note the result one position shifted to the left. We continue in this fashion and note all these partial results. Now it's time to sum them up. 1 added to zeros would be a 1. 0 plus 1 is a 1 again. 1 plus 0 plus 1 is a 2, which is 1 0 in binary. From our previous video, we know how to handle carry forwards in binary addition. When the result is not a single digit number, we note down the rightmost digit and carry forward the rest. Now 3 ones plus 2 zeros is a 3, which is 1 1 in binary. Note down the rightmost one and carry forward the other one. Now sum of these 5 ones is a 5, which is 101 in binary. Note down the rightmost digit and carry forward the rest of the digits based on their positions. In this fashion, we add all the partial results and get the actual result of multiplication. If in doubt, one can cross-verify the result by converting the numbers from binary to decimal. With no further ado, let's jump into the final arithmetic operation, the division. As always, let's recollect the division of decimal numbers. Unlike other arithmetic operations, in division, we travel from left to right, dividing each digit of the dividend with the divisor. Let's list down the multiples of the divisor as it will come handy. So we start with the leftmost digit of the dividend, which is a 1. We find the multiple of the divisor that is less than or equal to 1. And we know that's a 0, which is 13 times 0. So we note this 0 in the quotient column and the multiple is noted under the digit that is being divided. Then we perform the subtraction. 1 minus 0 results in a 1. Moving left to right, we fetch the next digit for division. Now we have 12 and the nearest multiple of the divisor to this 12 will again be 13 times 0. So we note down the quotient and the multiple. We again perform the subtraction and note the result. Then we bring in the next digit of the dividend for further division. Now we have 127 and the multiple of 13 that's closest to 127 is 13 times 9, which is 117. So we note the 9 in the quotient column and the multiple for subtraction. The subtraction gives 10 and we fetch the next digit from the dividend. And we continue in this fashion. 13 times 7 is 91. Note the quotient and multiple. Subtract and bring in the next digit of the dividend. 13 times 9 is 117. Subtract and we get 2. As all the digits of the dividend are now completed, that's the end of division. We can verify the result by checking if the dividend is equal to divisor times the quotient added to the remainder. Now it's time to understand division in binary. Division in binary is quite similar to what we just did in decimal, except it's quite easy. Let me show this with an example. In binary, as there are only 2 digits, there are only 2 multiples that we need to focus on. Just like decimal, we start with the leftmost digit, which is a 1. The multiple of the divisor that is closest to 1 is obviously 0, which is 101 times 0. And so we note the quotient and the multiple. The subtraction 1 minus 0 gives 1, and we bring in the next digit. Again the multiple of 101 that is closest to 11 is 0, and so we note the quotient and the multiple. Next we subtract and fetch the next digit. The multiple of 101 closest to 111 is 101, which is 101 times 1. So we note the 1 in the quotient column and the multiple for subtraction. You see, division in binary is quite easy because getting the closest multiple boils down to the following logic. For dividends like 1, those are less than the divisor, the closest multiple will always be 0, and so the quotient will be 0. And for dividends like 111 that are greater than or equal to the divisor, the closest multiple will be the divisor itself, and so the quotient will be a 1. We can represent this in the following table. Now let's continue the division with this logic. 111 minus 101 is 10. Bring in the next digit and we have 100. 100 is less than the divisor, so as mentioned, the quotient will be a 0 and the multiple a 0. Subtract and bring in the next digit and we get 1001. Now 1001 is greater than 101, and so the quotient will be a 1 and the multiple 101. And so we continue in this fashion. Subtract and we get 1000, which is greater than the divisor. So place a 1 in the quotient column and continue. Next we get 110, which is again greater than the divisor. So again place a 1 in the quotient column. Subtract and we get 1. Since the digits of dividend are now completed, that's the end of division. You can verify the division using previous formula. As always, if in doubt, convert to decimal and cross-check. So that was all about arithmetic operations. This is how we perform arithmetic operations in binary. And the ALU is able to perform all these arithmetic operations using some signs, which would be covered in upcoming videos. These arithmetic operations is what the A in ALU stands for. But there's also an L in ALU, and it stands for logical operations, which is the topic for our next video.
Hey there, hope you like the video. This video is part of series called Computer in a Nutshell. If you are new to computer science, then this is the only series you'll ever need to get started. Because this series will take you on a crazy ride, starting from what is a computer, to what's inside a computer, to how each part of computer works, leading all the way up to Introduction to Programming.
To get started on this series, you can head over to my channel and dial into Computer in a Nutshell playlist. Here, you can find all the videos from this series in chronological order. You can also find links to the videos from this series in the description of every video.
If you find this video informative, please share it forward. Subscribe to our channel for more such videos. Click here to watch the next video from this series. You can also check out our previous video from here.